Hello everyone and welcome back. Today I want us to look at Slint UI. So this is a UI toolkit written in Rust but offering bindings for C++, Python, JavaScript and much more. One of the best features about Slint UI is that it offers separation between business logic and the UI code because it comes with its own domain specific language called Slint. So we'll kind of describe your UI in a Slint file, and then once you bundle your application, it will all be compiled down and into a native binary. So very exciting projects done in Slint, and you can see some of them from their main website, showcasing like this is a charging station done by one of the companies using Slint. And from someone who uses Qt, I really find Slint quite similar because Qt has the QML part of it where you write your user interface in JavaScript like syntax, and then you write your business logic in C++ or Python, whichever the language you want to use for your backend. So Slint is rapidly evolving, and of late, of course, they added some plugin for Figma whereby you can just export your Figma designs into Slint code. Coming with the live preview, of course, you can see changes you're doing live as you change your code without having to recompile your application. This is really interesting when you're trying to iterate over your designs and see what fits well before you actually compile, because if you're compiling your backend, which might take some time, you might not really want that hassle of having to recompile over and over. So very nice tools that it comes with, and we'll be trying to look at it. So today we'll not really be working on the backend side. I want us just to go over an overview of the building blocks of Slint on the UI side. Let's see how we can write it, and we shall be doing mostly on the browser. No need to install any tools, but if need be, you can install Visual Studio Code, and Visual Studio Code comes with a Slint extension, so you also need to install the Slint extension that will get syntax highlighting for Slint, as well as if you want to make use of the this tool for live preview, you need to have the extension installed in Visual Studio Code. Similarly, I like also working with CLion. CLion also has an extension for Slint, and it's really beautiful because you can get to build and run your programs much faster compared to Visual Studio Code, in my opinion. So very nice tools, and it's very lightweight, as they boast about it, working less than 300 kilobytes of RAM with boards like Raspberry Pi Pico and much more. So I've seen some of the samples running in ESP32 boards and even lower boards than that. So let's look at some of these things. So for the documentation, how you can get use with how you can access the docs, there is actually there is a menu option here for docs, and if you click on this menu option, it will bring you to this page which gives a detailed documentation about all the different aspects of Slint. So starting from the guides, which just gives you a guide of how to make use of this documentation page, explaining how different sections are actually put and how you can make use of them. And then the second part is about the reference. So under the reference, it goes over the primitive types that build up Slint. So we'll be kind of working from this part. Things like strings, booleans, so basically the data types we should be having in Slint. So some of these basic types, then we have things like properties and callbacks. So if you have done UI in maybe tools like Qt, then you know something like properties. Properties are basically variables that notify you once they are changed or updated. So you can always bind those variables to some states, and then once those variables change, the state will be notified of that change and your UI can react accordingly. Callbacks, of course, you know, callbacks basically a function that you call once some things change here and there. So all these different tools, timers, we have them natively in Slint nowadays, so it will allow you to set some time intervals, and then you get a trigger once that time interval is actually elapsed. In terms of visual elements, we should be going mostly over this, how to load images, gestures, keyboard inputs, and much more. and see how just to play around them, get the basic feel of how to build some of these things. And then maybe in our next tutorial we'll look at how to build this Slint game window from scratch. And then lastly, if you want to see how to integrate some backend language like C++, Rust, TypeScript, and much more, you can have a look at this documentation on this page. So for our case today, we'll be making use of slintpad. So if you go to slintpad.com, it will bring you this page whereby it will give you a left pane whereby you'll be writing your UI code here, and then on the right page it will be showing you the result and output. So as it is at the moment, the syntax is we're importing some standard widgets from Slint. But for our case today, I don't think we'll be working mostly with these standard widgets, maybe later. First, I want us to work with the primitive types, and then of course the same primitives are being used to build these standard widgets. Standard widgets are things like buttons. Maybe you need vertical box. So vertical box is basically a vertical layout with some default paddings and spacings, and much more. So all these different kind of things are built from the primitives. So we'll want to work with the primitives first to understand how they work and some of the options it comes with, and then once we understand that, we can look at how to expand that out. So we'll clear everything out to start with, but basically an overview. So we'll be writing our code here, and then you can reload from here, and you can get the result output here. So we have a text output, an image here, because we have an image being shown here. It's called about Slint. So this widget contains some image content, although we can't actually edit it. And then lastly, we have a button here, given the text OK, so you can always click on it. So similarly, from this live preview, you can change the style from this drop down. Maybe you say you want to use a different style like cosmic dark. You can maybe say computational light. So if you're into some of these different kind of stylings, you can always change them from this point. Similarly, this live preview comes with some useful tools. If you don't want to kind of write your code here, you can make use of the visual design editor. So these two buttons here, we have the left pane. If you enable it, it opens this library having all the different kind of tools. And what happens is that you can drag any of these tools. I don't think I can do it from here. Okay, but yeah, so you can always drag some of these tools into the visual editor, and then automatically the code will be updated on your left. Similarly, if I close that for space, there's a right pane as well. This gives you the properties of what you select on this output. So if, let's say, you're working with text, so so I need to select this. So if you select text, then on the right pane you get properties, what you can change in the text itself. So you can always come here and tinker around and see how you can change some few data here and there, and that way your design is actually updated in real time. So if you change that to, welcome to our tutorial, hopefully that updates. So you can see on our code that's also updated here, and as well on the design as well. Yeah. So I do believe then if we come back with this selected, we can as well add, oh yes, you can as well add the path, so it's not really visible. So let's bring a text input, maybe let's put it there, select it, open the right pane. So you see you can get something here. Yeah, so that will now be a text input. So if you select that, we can select on that, and we can type in something we want to do now from here. So that's basically what this live preview can enable you to do. You can always use the live preview to lay out your controls and widgets, and then once you're done, you can come back here and do your stylings as you need. But for today, let's kind of get rid of everything, and then we shall start one by one. Also remove this. I don't think we shall make use of it at the moment. So how do we create components? So for you to have a component, you can have as many as you want within the same file. You create using the keyword component and give it a name. And then if your component kind of inherits from another component, then you need to add here inherits. So if you are into object-oriented programming, then you understand the concept of inheritance. You can say maybe inherits from a rectangle, and the first element we're working with is a rectangle. A rectangle is basically, from basic mathematics, a rectangle. It has a length and a width. The length and the width can be equal to form a square, but it's still a rectangle. And similarly, a rectangle comes with a lot of properties. So you come back to the docs and you come to reference, and then visual elements, you look for rectangle here. So a rectangle comes with a background color, there's a border, both border width and color, and then there's a clip property. Clip property allows us to kind of clip elements that overflow outside our rectangle. So if, for instance, we have this rectangle, let's just go back to how it was, and then let's put a rectangle inside this element, and let's do rectangle. So for color, let's give it a background color so we can distinguish it. Let's do colors.red, and then so it kind of fills the parent because there's another element within this item. So let's give it a width and height, that way it's not filling the parent. Let's give it a width of, let's say 300 pixels, and let's give it a height of 200 pixels. Yeah, so we can see the difference between our background and the rectangle you're working with. Now once we do that, let's also add another rectangle inside this, and then let's test the clip property. So I will do a rectangle here. Let's give it a colors blue, background of blue. So it fills the parent item. So to kind of limit that, let's give it a width and height of 100 pixels. 100 pixel. So in Slint, most of it's actually strongly typed. So for items like width, height, they are of type length. So if you come back to the docs, it actually details that under primitive types. And if you come to, you have booleans, you have strings, just like regular, because the backend is written in Rust, so kinda they have some similarity. So for angles, you have to use the degrees or radians. So you have to specify it, or even turns when you are giving the value. For duration, you have to specify the milliseconds or seconds. They are very strongly typed. So for length, that's what you're working with. For x, y, width, and height, you have to give it in terms of pixels or points or inches or millimeters. So you have to be very specific on how long you want to work with. For percent as well, it has to be given in terms of percentage, as it's actually detailed here. So all these kind of items you might need to go through first to understand the basic types. That way, when you're working with the UI side of things, you don't kind of get a bit of a confusion of what is actually happening. So let's come back here. So now that because we don't have any items, automatically this will be centered in the parent rectangle. So we have the inner rectangle, which is blue, and the outer one, which is red. Now to position our elements, we can make use of the x and y properties. So you can do x and I can do 0. So if you do 0, automatically the x value for a blue rectangle becomes 0, so it ends up being aligned on the left edge of the parent red rectangle. So we can even make this value negative. That way it kind of overflows outside the parent. Let's give it a 10, negative 10, and then now you have to specify your pixels, and you can see our blue rectangle is kind of overflowing the left. So if our parent had the clip property set true, and so the overflown part of the blue rectangle is currently clipped out, so you don't be able to see it. It will not be showing up again. That's actually overflowing over the parent rectangle. So with rectangles, you can also add things like border width. I can give it 2 pixels, and I can do border color as well. Let's do colors dot, so we'll do green. So you'll see a green border being drawn here. You can smoothen the corners by doing border radius. Let's give it 16 pixels, and very nice 16 pixels is now showing all across. Similarly, rectangles allows you to add things like drop shadows, so you can also add drop shadows if you need. I think not many items allows you to have drop shadows, so with the rectangles you can have a drop shadow, so it can make a nice element for you to make your cards and things like that. Another element we can look at here is we can remove this is text, because that's what we normally use a lot. So we can have a text element here, and inside the text element we can give it a value of property of text, and let's just do hello world. And so with any element you write, you have to delimit it with a semicolon. If you come from C++ or the likes, you understand this kind of format. So automatically it's centered, so you can manipulate some properties of text. For instance, you can do font family. If you want to change the font family, if it's italic or not, you can give it a boolean here. And then font size and font weight. Font size is the size of the font you want to do, so we can do here, let's say 20 pixels, and our font automatically becomes larger. For the font weight, it's basically if you want it to become very bold, so you can do a value of 800 here, or you can even do value of 300. I think that's wrong. So we come back here to text, then there's font weight here, so it can give you the values it expects. Yeah, so you can give it values is an integral value, so you can give it any value, maybe from 100, which is the lightest, to 900, which is the thickest. So we're doing it right here, so we can just do 800 here as we did it, and then you can reload. So the whole thing has collapsed into that small part because our parent element does not have dimensions, so it kind of takes the size of the child element. So to avoid that, let's give it a width here of, let's say, 500 pixels and a height of 400 pixels. Good. That will have a definite size to refer to our elements here. So with text also, it comes with other properties. So if you want to do letter spacing, overflow, and all these kind of things, if your text is longer than the size available, you can drop your text to the new line. You can play with the strokes. Also, you can rotate your text. So if you want to have maybe a vertical text, so you can come and do all these kind of things, whereby you give the angle, which is in this case 45 degrees, and then you give the reference point in X and Y, whereby the rotation will be happening. So with that, I think you understand how text kind of comes in. So in every UI you'll be working with, you'll always have UI, you'll always have text elements, so you can see how you can play around with it. Another interesting element to work with is image and path, and I'll explain the difference. So with an image, images are basically the visual image you might want to put, and how it works, you need to have a source image. So either it's locally or it's actually online. So with the slintpad, I do believe you can only do online images. So I'm trying to find a valid image URL. Yeah, like this. So you can get this image here, and then you can come here. So with images, you just do an image here, and then you do source and you give it an image. So always for images, you have to wrap them within the @image URL. That's how the Slint docs expect it, and then it will be shown here. Similarly, you can now manipulate some other parameters. You can do also the width. So all elements have width and height, as long as the visual elements remember, not all elements will be visual. For instance, things like timers are not visual, they're just kind of logical, so they will not really be having the x and y, width and height, because they don't occupy the visual space. So we can do even 20 pixels here, and you see our image kind of becomes very small. So yeah, so you can also do rotations. I do believe that. So with images, you can also define how you want to fit your images. If you want to fill, contain, cover, preserve, and much more. In terms of properties, and I think we need to talk about properties before it's too late. So if you have some data that you want to be changing, or whether it's changing or not, you can use properties. And in our docs, I do believe properties is described under primitive types. Let me check. Not here. Oh yeah, properties. Yeah. And common properties and callback. Not really. And so with properties, how do you define properties? So if, let's say, you want the image URL needs to be passed in from another component or from an outside widget, then we need to have a property here whereby that data will take in, and the property expects you to give it the data type you're working with. In this case, I will do a string, because a URL is basically a string. And then let's give it this property a name. I will do our logo, as simple as that, and then I can leave it as that. So as it is at the moment, this is a local property, and any component outside of this demo cannot access this one, because it's actually like private. If you understand how the public-private ownership kind of scope works in C++, if you're doing object-oriented programming, this is kind of the same. So for you to allow this to be accessible from outside, then you need to prefix it with a property in. In means it can be set from outside, so it's an in property. Another property available is out. Out means that basically those outside can read, but they cannot write to it. So in means those outside can write, but those inside cannot write. Out means those inside can write, but those inside, any element inside this component can update this value if it's out, but those elements outside this component cannot update, they can only read from it. And then we also have in out. In out means both sides can read and write from this property. Simple as that. So that is actually also defined within the docs. Let me get that. Yeah, so under the docs, we have this element of properties, and it basically explains to you what the concept of properties. So you can always define the type within angled brackets. So if you have worked with templating types in C++, then this might look a bit familiar, whereby you have to define the type within the angled brackets, and then you give the variable. So there's an aspect of how you define the scope for these variables, as I explained earlier. The in is an input property, out is an output property. So for out, as I said, the component can set the values, and it's only read only for those outside the component. In out is basically allows you to read write. So by default, if you don't specify this scope of in or out, it becomes private by default. So it can only be accessed from within the component itself. So if you want to play with these things, then for a logo, in this case, I can take this out and replace it by root dot our logo. So yeah, I think this needs, it's not a string per se, it's actually supposed to be an image type. I was wrong here. Yeah, so our image is also back. So if we remove that and just comment it out, our image actually goes away because there's no source image, so nothing is being displayed. But if we bring it back, our image is being displayed. So before we look at any other elements, let's look at how you can create different components and make use of them. So for this case, I can do another component here. So you define it by using the component name here, the component keyword, and then you give it a name. So let's call this my rectangle, and inside our rectangle I want us to inherit from a rectangle, a real rectangle, that way. Inherits, yeah. So it's warning you this is not currently being used. So similarly, I will just take all this out and I'll put it here, and then I'll replace it by my rectangle. Now I think this needs to be up here, and similarly we need to define this property. So this property is here, so you also need to put it here, and I want to only define this logo from outside this element, so this component I mean. So I will only make this an in property, and as an in property, since we're using it here, we can now define our logo from this point. Now since we already defined our logo here, I can bind it directly and do root dot our logo. So there are two things to keep in mind. There's the root and you have the parent. So if I'm in this item and I want to refer to the parent item here, I can use the parent this way. So if I do parent dot, it gives me properties for the parent item, which is still this rectangle. So since the rectangle is the parent, I can still access it from using that way. But if image was nested within a lot of different components, then it will give you the immediate parent properties. The root in this case refers to the root element. So if this component is in this component specifically, this component becomes the root. So this is the root component, and then all the children under it will be different components now, which if they want to refer to the root here, they have to use the root keyword. You can also give, let me just format this. You can also give your different components IDs. So I can say maybe this is our image, that's how you define it. So it has a syntax similar to what Go uses for defining variables. And so it's very interesting. So you can now refer this image using the img variable here. So this is now the ID for the image. So this is for IDs, and then we have our component. So let's look at, since you've seen how an image works, let's also add, let's look at our next property in this list was a path. So we come back to primitive types. Let's look at, which elements? Path. So path, think of path as SVG, scalable vector graphics, SVG. So paths allows you to define a path, which is basically an SVG kind of drawing, and you can either define your paths from scratch using the different building blocks that it offers. So it offers some things like, if you've looked at how SVG works, it has some of the things like how to move the drawing pen from one point to another point, drawing an horizontal or vertical lines, drawing a line from one point to another point. So path basically works in a similar way. And to understand it, let me just remove all this here for now, and let's bring in a path component here. So you define a path that way. And then for path, there are two things. I can first give it a width and a height if I need be, but of interest I need to define the view box. So view box height, let's do 300 pixels, and then to do view box width, let's also do 300 pixels. So the it's not supposed to be in pixels, it's supposed to be that way. Yeah. So what you're basically defining here is the box within which the SVG itself is being drawn inside, which is different from the path. So the path can take the whole parent size, but where you're drawing your SVG items can be a small section within the parent item. For instance, if you look at this button here, so this all is the button width, but this small image or SVG being shown here can have its own view box within that small encirclement. Yeah. So with path, first let's define the stroke. So the stroke width, let's do with 2 pixels, basically how thick the stroke needs to be. And then the stroke itself, let's give it a colors dot, let's use red just for fun. So with those two defined, let's move our pen to, let's give it a dimension of x, let's do 30, let's do y also 30. So basically there's nothing being shown here. So moving, basically saying lift your pen to a point 30 and put it there. Now to draw something visible, let's now draw a line. Let's do line 2. So line 2 expects you to give it some coordinates. So let's do x is still that, let's do x is 100, and let's do y as let's still do that. So we have an horizontal line. So you can now see you are drawing a line going that way. You can also draw curves from here. So you can do cubic 2 if you know how to use cubic 2. So cubic 2 expects some parameters, I think 3 or 4, for it now to draw a cubic 2. Similarly, you have arcs, so you can also do an arc, and arc also expects some parameters. So if you understand how to work around with these different things, you can use them to draw a very nice SVG shape on your screen. Now, alternative to doing all this work manually, I can get rid of all that and come back here, is you can give it a path string. Is it a path? Let's confirm. Oh, sorry, it's supposed to be a command, not a path. Yeah. So alternatively, you can give it a command, and this command basically describes how the path should be drawn. So what this does is you're moving the pen to a coordinate of 0, 0, which is the origin of the view box, and then at that point you're drawing a line to 0, 100. So 0 on the x, y, so you're drawing this vertical line to this point where y is 100. At this point you're drawing an arc, and with an arc, this arc expects things 6 parameters, so these parameters until here. So you're drawing this arc, then you're drawing a line back from this point to x is 100, y is 0, so that is this point on top here. And then at this point you're closing the drawing by using the z. So this z basically says connect this point to the starting point of our path. So that's what this command does. So if you, no matter how complex maybe the design you want to have with, you can always work around with these commands to kind of draw the different shapes you want to work with. So that's the path component, very useful if you need to embed some SVG drawings in your UI side of things. Now, we have looked at how to work with images, paths, rectangle, and text. Another interesting thing to look at is touch area, because you need to be able to capture user input to do that. So let's remove all this, and let's bring back our rectangle. And inside our rectangle here, let's give it a width of let's do 200 pixel and a height of 100 pixel. Let's also give it a background color, and we'll do colors dot green. Oh, gray, that's still fine. To give us this box, let's give it a border radius of let's say 16 pixels. Still works. Yeah, so at least it looks a bit nice. Now, if you are trying to build a custom, let's say like a push button, whereby user needs to press for it to do something similar to what we have on these buttons here. So maybe let's add a text within this. Let's give it a text of our button. So we'll just be working with this button to make it look a bit nice. Let's create a font size of 32 pixels. Okay, that's fine with me. Now, let's increase this a bit. Okay, that looks nice. Now, we need to have some interactivity with this button, such that I can be able to click on it and do some actions. So to do that, we need to add a touch area. So inside here, we'll just do a touch area that way. And let's give this touch area an ID of TA. That way you can use the TA to refer to this. And okay, we'll not need that. So let's do this. Let's change the background color of our button every time we click on it. It will be something interesting. So to do that, let's define a property here that we need to manipulate. Okay, so let's create a function within this. Let's just do get color. So with get color, we need to do here is when you are clicked. So this is the callback from touch area. So that when you are clicked, let's call get color for now. Just that way, as simple as that. In our get color, I think it should be interesting to define a property here. Integer, let's just do color index. Let's do a 0 to start with, and then also we'll do a property. Let's do of color. Let's just do color model. When this method is called, what shall first do is let's increment the color index. So we'll do color index that way, and then let's check that the color index, if it's greater than actually 2, then we revert it back to 0. Yeah, with that, let's return here color model at the color index. Good. So with get color, good. No, I think we should assign this to our background here. So we'll do parent. So let's give this an ID of button. So you can refer it from here. Good. So if we come back here now and we click on our button, we'll see the color changes now, because anytime we click, this method is called. What it does, it increments our index by 1 and checks if the index is greater than 2. This ensures that our index can grow to even 10, but you only have 3 elements. So first option is to clip it within a value of 2. Another option could have just to use a modulus operator to mod it by 3 and see and get the value out, but anyway, that still works. And then you can assign the color here. So from this button click, you can do absolutely any kind of thing you want to do. Similarly, you can come here to background and say, maybe let's remove that for now and do if touch area dot is, if the button is pressed, let's have gray color, else let's have green color. So we can confidently disable that for now. That way, when we click our button, we can see some state change. You can also make use of states. States is something available within Slint, whereby with states you can define different kind of conditions that meet a particular state. For instance, maybe when your button is clicked, you have rounding of, maybe the border radius changes, maybe the background color changes, the font width changes, and much more. So all this you can achieve using states, but maybe you can look at that later or in our future tutorial. So that's how to add interactivity to your to your UI. So first, you can use the touch area to define basically where you need to add some mouse interactivity, and then from there you can bind it to the clicked callback, and this callback you can now bind it and use it to execute some other actions. For instance, if you look at this UI, you can bind the clicked to refresh the whole thing, or even to open the different sidebars as you prefer. Now, we've looked at the touch area. So for keyboard input, I will not look at these two. So for keyboard input, for of interest, let's look at the text input. Basically, how do you get some text from the user? So if you come back here, we'll not remove this because we'll be building on it slowly. Let's add here text input. So you will not see anything yet. Why? Because these two items are currently overlapping each other because there's no layout defined. So to lay out these items vertically, you need to use the vertical layout. Take note that there's a difference between vertical layout and vertical box. Vertical box comes from the standard widgets, and this has some predefined properties set already. With the vertical layout, you have to come and define some of these other things yourself. For instance, let's just format this first. Let's go up one. So automatically, once I do that, you see things have suddenly changed. So let's give this a width of parent, height, or let's do 50 pixels. Let's do it. Hopefully that, yeah. So our text input is kind of very small here, and you can see it. So you can as well type it here. So maybe when our button is clicked, so let's give it an idea of text input, and then when our button is clicked here, let's kind of clear the text by doing text input dot text. Yeah, so when you click on this button, it gets cleared, so you can come and type something else and much more. So you can basically play around with that and see. So if you're building, let's say, something like a form, you can have different text inputs and then you have your submit button at the end. So this is kind of the same idea. Don't worry about styling. Styling is something you come and figure out yourself and see how to do it. So with vertical layout, there's the vertical layout and the horizontal layout. Some of the properties you have within vertical layout is the spacing in between elements. So you can come and do your spacing, and you do, let's do even 50 pixels. You see how it will space. It kind of spaces there, put some space in between here. And then there is the, since you're laying out items vertically, there is the, let's even do padding of 30 pixels. So you can always also add this spacing on the left, on the top, on the right, padding top. So do 30 pixels. Yeah. Anyway, just some ideas you can work with, so you can see how to make use of that. With our text input, of course, you can come and add some other items into it. So we've basically worked with just setting the text, but similarly you can change the color of the text, font family, font weight, just like the normal text we had initially. It offers some properties like has focus to know when the text has been text element is actually in focus. Maybe someone is typing in some text or not. Of interest, you can also see something like input type. So if you want to only have like password type of input, whereby you show the user some asterisks or something else, instead of just showing whatever the user types in, so you can use the password type. You can also limit to numbers, decimals, and things like that. So it also comes with some very nice functions. So if you want to focus on a text input, maybe you are switching different pages, and you want to, once you switch to a new page, the focus of a particular text, the text in a particular page gets the focus. You can use this. You can also clear focus once you're done selecting the text and clearing the text. You can copy, cut, delete, and much more. So all these different properties you can work with to build your UI as you want. So we talked about the layouting issues. So with the vertical layout, you can add some spacing. So to kind of visualize the layouting here, whatever we had here is not really nice, so we can just use rectangles, and let's give it a background. Let's do colors.red. Good. And then let's just do padding. That way it covers all across. And then let's remove this. So by default, if I only have one element within the layout, it will kind of fill the whole space. So look at, if we add a new component here, it kind of splits the two, it splits the space equally, similarly that way. So with the spacing, maybe you can just keep it down to 10. Yeah, that looks nice. So it kind of shows something like a grid, whereby you have different kind of this. So that's the vertical layout. So if you just swap this to a horizontal layout, similarly you can see it's being laid out horizontally. So you can use this vertical horizontal to see how to put your different components on screen. That way you can achieve your UI. So just an edge case. So maybe when I've set this to horizontal, and let's fix the height of the last one to 30 pixels. Now with this in case, you see now that this one is kind of stuck here. It's not filling the whole space. Maybe I want it to appear on the bottom or the top. So the layout comes with some properties by default that allows you to kind of align items. So if you come to alignment here at the bottom, it basically defines how you want to put your so do you want to stretch. So this will ensure that the elements fill the remaining space. So you have center, start, end, space in between, and much more. So if you are aware about how the CSS flexbox works, so this gives a very similar, takes a similar approach. So if we come and do here alignment and do center, you realize that now we lose everything just disappears. So we need to define also the width here, and when I do that, that now shows up. So let's do equally the same. So when you're defining all these different alignments, center means align all our children within horizontally center here. So you have equal space on both sides. The reason why it was breaking earlier is because our rectangles didn't have any kind of defined dimensions, so that's why it's breaking. But if you bring stretch here, and let me remove that. With stretch, it basically says fill out all the remaining space that's available. So those elements that have fixed dimensions, they'll be pushed to the peripheries as much as possible. So this will be useful if, let's say, you're building a UI and you want to have let me just move that, let me bring it here. So so for height, let's remove the height for this as well, and the height also for this. So this will be like your sidebar menu on the left, the main content area, and then on the right you have maybe some properties menu or things like that. So similar to what you have your sidebar menu that contains some library of widgets and things like that, and then on the right you have some property menu as well. Yeah, so you can use this different kind of layout, horizontal, vertical, together in combination to lay out items within each other. Yeah. So lastly, what we should be looking at in this section is I think for horizontal, I've kind of alluded to it from what you've been able to do. Of interest, look, we also have something called horizontal and vertical stretch, so you can make use of that. This basically defines how much of a stretch we need to work with within the different layouts. So you can adjust different stretching, that way different components that stretch differently to occupy the remaining space. You also have a grid layout, so similar to horizontal and vertical. The grid layout allows you to define the different rows and columns that you want to put your elements in. So with the grid layout, you're basically defining rows, and each row will have different components. And now with grid, you can have components that span more than one row or column using the row span and the column span to build very nice UI interface. So I will not go into that currently, but you can look at the docs and it will give you some information about how to make use of the column span and the row span and much more. Okay, so lastly about Windows. So since we are working within the slintpad, so you might not really see how to work with this, but if you create a project, by default you'll get a project that contains this kind of a layout whereby it inherits from window, and this window is what will give you things like the window controls, like the minimize, maximize, close, all these things, as well as for desktop applications you normally have the application logo on the far left and then the window title on the top. So this will give you all that information. If you want to use it to be full screen application, you want to have a background color on your window and much more, so you can make use of this window. Similarly, things like if you want to have pop-up windows within your application, so you can make use of this. and I do believe we can spin one, so let me check if that's the case. So let's see if we can do pop-up window. I do believe we can, so let's get it out over here, and then let's give it a width and a height, of 200 pixels, and let's just add a touch area here, and clicked. Let's do pop-up window to show. Good. So if we click this last one, nothing shows. So I think maybe we need to define the background. Yes, let me just check on that. Let's do blue. Yes, it's now showing. So basically a pop-up is it's just another element that will be drawn over your current window items. So that's why it's showing at the top left here. So to center it horizontal and vertical, you might need to provide X and Y here. So for X, we'll do root.width minus self.width. Then you divide that by 2. So if you do that automatically, it will be centered horizontally. Vertically, you can also do the Y part. So just still do root.height. So you're taking the root element height minus its own height, and then just dividing that by 2. Good. So this will now be centered horizontally and vertically. Yeah. So yes, pop-ups are supported here, and we can make use of them as you see. So for most pop-ups, I think it's closed automatically when you click on them. So the docs will be a guidance for that. So there's a close policy. I think by default, this should be the default close on click. Yeah, so when the user clicks, the pop-up will just automatically close. So you can change the policy, maybe to now auto close and this like that. Then you can close yourself once you've done with some operation. So you can also use pop-ups to, maybe some operation is taking some time. You can use a pop-up to show the progress and things like that. So quite interesting. For menu bars, so menu bars was recently added. You can use it now to add system like menus, and menus are what you normally see in most of the Windows. If you're using maybe macOS, you'll have it on the top left here. If you're using Windows, it will usually be on the top part of the window on the top here. So you'll have different drop-down menus that you can select different kind of things like that. So this was recently added, and I think it needs to be within a window itself for it actually to work. Yeah. So it is native dependent. So depending on how your system implements menus, you might have different kind of behaviors. So you always need to keep that in mind. Then for dialogues are basically what you can use to do interaction with the end users. Maybe you need them to confirm an action. You can make use of dialogues. And context menu areas. So the context menu is basically the menu that opens when you do right click. So like in browsers, you can see this kind of context menu being shown up when you right click. So this basically defines an area whereby this will be taking place. So you can use it to define, maybe if you're making a table and you want users to right click on a table row and do some actions. So this could be interesting for you to use. So lastly, something I've not talked about is something called callbacks. And callbacks is different from properties. So properties and callbacks are a bit different. So how you can think of callbacks is if I need to propagate an action from this rectangle here, so let me replace my rectangle in this part. Let me just bring it actually here, and you can basically see what it initially had is this, but now I need to propagate. Let's add here touch area. So with touch area, that means I can click on this rectangle, but I need the action being done should be outside this component. So what I can do is I can propagate this clicked from this touch area outside this component using a callback. So you define a callback by just doing callback, and I can give the name as clicked. Simply, if it requires some parameters, you can add them within this or not, so you can leave it as it is. And then inside this, when it's clicked, I can do root.clicked. That way I can basically call the callback. So inside our rectangle here, I can basically come and do now clicked, and from here we can actually just show this pop-up we were doing initially. Let me save that. So if you click on this, the pop-up will still show. Yeah, so as expected. So you can use callbacks to propagate some actions outside the component you're working with. That way, if you are now binding logic, you want to bind the UI to your logic, you can propagate these callbacks outside. So one other component of interest you can show is the global component. So we have been working mostly with these components we define in this sense, and we need to embed them one in another to kind of build a UI hierarchy. Now, we normally have global component as well, which can be accessed from any component working with, and this can be interesting if you're maybe for things like themes which need to be uniform all across, or some states for your application. For instance, if you have very complex navigation and you want to always ensure that from whenever you are in the application, you know what's the current state of your navigation, so you can make use of the global component. So maybe let's call it just maybe app state, and in our app state, let's add a property called, maybe it's an integer type. Let's just do counter. Let's start with at 0. So with that put there, maybe in when we click our touch area, let's just do app state dot counter, and let's add 1. Oh yes. So remember to put annotate your properties, that way you can access them from elsewhere. So that way this is now resolved. And to display this one, so let's come back to one of our rectangles here, maybe the major one, and just add a text element. And for our text value, let's add that one. So let's do our counter, and you can use the backslash, and then you use these curly brackets, and then you can just do upstate dot counter, and then don't forget your semicolons. Yes, you now have your counter here. You can just comment out the whole, and as you can see now, we can just click and maintain the states across without any worry. So I'm clicking on the left here. So basically you can use this global one to ensure that to maintain your app state across different components. As you can note, in our root components, we have this export property set, and this is important so that we can be able to access our component from outside this current Slint file. So we have to export it. Similarly, for our global, If it's just a state for a local, local file, no problem, you can leave it as it is. But if you need to access it outside this file, then you need to export it by adding an export here. So if you have worked with things like React or whichever, which normally use this kind of a syntax, this is kind of similar. So you can export your different global or components, and you can access it. Once exported, you can access it from outside the particular Slint file you're working with. Similarly, you can access it from your backend logic code. Yeah. I think that pretty covers most of the basic primitive types you want to work with. So just as a side note, by default, Slint defines some global structures and enumerations you need to know about. For instance, something to do with font metrics. If you want to know metrics about a particular font and what you're working with, you can look at what's available here. For things like keyboard modifiers, it's available. You can use it maybe to know when the Alt is pressed or the Control is pressed. That way you can know how to find different shortcuts. For keyboard events, that's also available. For points as well, that's same available. For pointer event, so this will be interesting if, for instance, you want to filter out mouse events. This will be something you might need to know and check. Pointer scroll events, standard list view item, and much more. All these different kind of enums are available for use, and you can make use of them. And then we also have global functions. For instance, for maths, for any math related methods and functions, you can access them through maths dot. And then if you want to find the absolute value, you want to find the square roots, you want to find the ceiling and the floats and the floor for floats. Basically, that means rounding up or rounding down. So you want to round particular things. You want to clamp allows you to limit values within a particular range. So all this is available, and you can make use of them. So if you're working with any trigonometric functions of interest, of course, our trigonometrical functions take in, remember, you have to specify either degrees or radians, and that way you can always know what to convert to or what to convert from. Lastly, if you want to be able to do some continuous animations over time, so for instance, you want to run animations forever, that basically they loop and loop and loop forever. So if you use the animate, the normal way of just doing animation, it will run once and stop. So to ensure that you run forever, you can use now this of animation ticks, and this will give you a duration that you can work with to ensure that your animation runs forever. Lastly, if you want to log out some of the things you're working with on screen, then the debug method might be very interesting for you. And this allows you to log out from within Slint directly. You don't have to switch over to your backend logic code. Let's lastly look at how to run animation within Slint itself, because that will be of interest. So let's go back to what we had done earlier and look at our first button here on the left. So if, let's say, we need to animate that button once we click on it, we can come here to border radius, and let's change this border radius once we click on the button itself from maybe 16 to 32 and back. So we can bind that to what we had initially, and let's do that pressed. If it's pressed, let's give it the 2 pixels, else let's do 16 pixels. Now, so if our button is pressed, let's do the 2 pixels in terms of the border radius, else let's do 16 pixels. And now, how do we animate between the two? So currently, if you click on this button, you will see that abrupt change between the two border radius, because it's an instant change between the two. And remember, we're still counting from our counter. So we can have animate, and animate expects you to give it a property. So in this case, we are working with border radius. And inside here, you can give it a duration. How long should animation take? I will do, let's say, 300 milliseconds. And lastly, we can provide the easing curve, and I will do is, I don't know which is good, which is bad, so it's up to you to to determine what works best for your animation. So you'll see, like when I click now, there's a very nice ease in and ease out for our border radius. We can also add the background here. So since our background is not changing currently, there is nothing to see. But if you have, let's actually add a new color here, such that when you're pressed, let's do maroon. When you're not pressed, let's just do show red. So this is a ternary operator whereby it says if this condition is true, we'll evaluate this, else when it's false, we'll give out this. So when you click now, that's not working. I think that's not working, and I'm not sure why. Yeah. So we are overriding our color from outside, so it will never respect the internal color. Yes, so that was where the issue was. So you now see a very nice color change between red and green. I don't know if that's the best for UI UX, but you can see the transition between the two of them, and that can be done using animations. Similarly, you can use animations to maybe change the width, the height, and different kind of things. Growing and shrinking, you can use animations for that. So anytime the property changes, you can ensure that the change is kind of smooth, so you don't have that abrupt change in dimensions or change in size and things like that. So animations is something interesting you can also work with, and very simple. You can apply different animations whenever you like, and so with that, I think that brings us to the close of our overview of Slint basic components and tools. So just as a side note, Slint also offers some standard widgets, and this also they actually do build on top of what you've talked about. For instance, if we're talking about a button basically is made of a touch area, a background, a text, maybe a logo or an icon on the left, and much more. But you can build yourself from scratch. The only drawback that the standard widgets kind of offer or have is that you can't customize them by inheriting and changing some of the properties. You need to build yours from scratch. So maybe that will change in the future, but I'm not sure. But that's something you need to always have in mind. So if you need to use some of these basic widgets, then you need to know that in mind. Additionally, if you need to build complex layouts and complex tools, of interest that you need to be aware about is like the list views. With a list view, this will allow you to lay out data maybe horizontally or vertically from a model. So if you have a model, you can use it to iterate over, you can use a follow-up to iterate over a model and populate your list view. A list view is what normally used mostly to display maybe data from in a database. You have a lot of items and you want to display them to a user. A list view can really come in handy. So you can use a list view, and it allows you to kind of scroll up and down the list that you have. Scroll views is what you're using in this page. Allows you to scroll if the content is larger than the area we're working with. A scroll view can come in handy to allow you to scroll up and down to kind of visualize the whole content here. The standard list view is similar to a list view, but the difference is that now we are using a standard list item as well. So and some of the spacing paddings is kind of set already for you, so it might fit what you're working with, or it might look out of place. So always experiment and see. If it does not fit, you build yours from scratch using the list view that's provided already for you. Similarly, a tab widget. Tab widget is what normally used to select different tabs on the top. So if it does not match what you like, build yours from scratch. It's quite simple. Text edit, similar to what you have as a line edit here. By now, this allows you to have many different lines of text as much as you can. Think of it like what you normally see in text editors, those long text inputs that you have. And then lastly, some of the interesting things, of course, with Slint. Earlier we talked about the About Slint, so it's just a very small widget, but because of the licensing of Slint, if you are using it for desktop and maybe WebAssembly, you're given some, I think it's a free license. The only condition, you need to display this badge within your application that's actually made with Slint. For if you need to have a date time picker, so they kind of offer one inbuilt, so it's really helpful because that's some of the things you need to always be doing, picking some dates and time and things like that. And then lastly, this is for the date picker, this is for the time picker, so you can kind of use it to pick the time, 24 hours, 12 hours, and the likes. So Slint, that's basically the overview. A very interesting UI toolkit that maybe you need to have a look at it. On the language integrations, maybe in the near future we'll be looking at C++ of interest. That's what I've been using mostly, and it will be really interesting seeing how to integrate. And as I said earlier, you can see even interaction with things like ESP boards. But if you have a board that's not currently supported, you can see how to kind of integrate it. Lastly, I know this is the first time I'm saying so. Lastly, Slint allows, since it's very lightweight, you can embed Slint within another existing UI toolkit. So by default, I think they do offer. By default, it comes with embeddings or embeddable backend for Qt. I think I've seen Qt, but in their GitHub code, because you can see the full UI code for Slint on GitHub, so you will always find how to kind of embed within other applications. So maybe if you have your application maybe written maybe in GTK and you need to use Slint maybe for maybe things like plugins and whatnot. So they give some examples on how you can do that in terms of I think I've seen one for Qt and other tools, so you can kind of see what they're doing there and try and implement it now for the specific platform you want to use it for. So very lightweight, very interesting project, and you'll really find it you'll find it to be a very interesting toolkit for use case. There are many different kind of projects that need, so you can go through the documentation, the different tools they're showing you, and much more. So in their source code, they're showing many different examples, so you can go through, look at how they're implementing it, and find some synergy between what they're doing and what you really want to implement. For embedded systems use, remember that there's a license that you need to go with it. So check on their docs, and pricings. So this will kind of explain to you everything you need to know about pricing. If you worked with Qt before, you'll find this licensing very simple. For Qt, it's a bit complicated for embedded use and whatnot. So, and it's also very expensive. For this, I think, from my understanding, maybe you're a small enterprise, then you will find this will be very cost effective if you're doing for commercial. But if for personal and whatnot, then you might find you don't need to pay anything. So hope you find this tutorial interesting and helpful. So have a look at it, play around with it. If you have any questions, we can discuss them or whatnot. If you need help from the Slint team, they have a very active GitHub contribution as well as discussion. So look at it. So you can see as little as 2 days ago, 18 hours ago. So they are very active in what they are building and what they are on what they are building. So look at that. If you have an issue, you can send some issues here. Pull requests, discussions are also available. Contribute if you can, and you can make an effort to making the whole ecosystem better for all of us. With that, thank you for following through. I'll see you in the next video. Have a great day. Bye bye.